Myself, Dr. Jaishree Jain. I am associate professor in CSE department, Ajay Kumar Engineering College, Ghaziabad. So today we will learn about the topic that is reinforcement learning. So what is reinforcement learning? This is a machine learning technique in which we use a agent based learning, and this learning actually used in gaming or in robotic system. So we can apply this kind of learning in real time system actually. So we have to just understand what is reinforcement learning. And this Q learning is the algorithm which have been used in reinforcement learning. So the outline of this topic is introduction of reinforcement learning, and then what is the model of reinforcement learning model. This is MDP model, and learning task. Then algorithm is Q learning basic and its algorithm. So just we have to understand what is reinforcement learning and what are the algorithm used in reinforcement learning. So firstly, I already told what is reinforcement learning, in which we have some applications and the output of the system is a sequence of action. So this learning is actually when we play any game, so we have to just perform the steps or action, then we have to just reach the any level. So this is the actually this learning help user how to move and how to reach to the target. So we have some sequence of action here, and in such a case single action is not important, because we have to just reach, we have to win, either we have to win or either we lost the game. But if we correctly move at each step, then we will definitely win the game. So this is a actually collection of the action, not any single action. We can train our model with the number of actions should be there, so that we can help the user or machine will learn how to move the step and how to win the game. So game playing where a single move by itself is not that important one. So we have sequence of actions here. So in case of the agent act on its environment. So agent is what? Agent is a one we can say ki there one be a one robot or any virtual person which will help to user to move to the further step. So environment means which have the interface of game. So we have an environment, we have an agent, and it receives some evaluation of its action. So this is reinforcement. Reinforcement means we are performing some action and user is moving to the next state. So it is not told of which action is correct one to achieve its goal. So how we can find out which action is actually correct or which action is incorrect. So for which we have one variable that is reward. If the agent will move on to the correct direction, then if action is correct, then it will get the reward. Just like when we play any game, we get the coin. So if action is correct, then it will get the reward. So we have just, if the agent is moving correct action and getting the reward, so we can say action is correct. And if it is not moving to the right direction, then it will not get the reward, it will get the punishment. So we have to just check whether agent is moving to the correct direction, then it will get the reward. So when the reward will maximize, then we can say set of action performed are correct. And when reward is not maximized, then there will be a problem of in any action. So machine will detect which action have been incorrectly moved. So this is the basic formula, basic of the reinforcement learning. So I already told that player know whether it win or loss, but don't know how to move at each step. So this is very important, how this learning will help the user when the game system or any like traffic control system is there that measure the delay of car, but don't know how to decrease it. So these are some real life problems where we can solve it with the help of reinforcement learning. So like considering the teaching, how we teach the dog means cannot tell it what to do, but you can reward or punish. So just like we train our dog, if it is listening us and doing the correct action, then we reward the dog, otherwise we will punish the dog. So here the concept is same. So we train our computer like we train our dog. So if dog obey and act accordingly, then we can say we are going to adding the reward, or when it will not perform the action, then we will just punish the dog. So means we have here positive value. If the agent will move on the correct direction, it will get the reward, means positive value. And if it is not moving to the correct direction, then it will get the negative value, means punishment. So this is a concept. So the reinforcement learning is what? The learning system which get the punishment or improvement. The reinforcement learning is selectively retain the output that maximize the received reward. So mainly the output, what is the output of reinforcement learning? Maximize reward. The reward where we get the maximum value, so we can freeze those action for next time. If next player will play that game, so it will get the instruction, or it will get the some played games. So we have to just freeze those action where we get the maximum reward. That will be the experience for next player to play the game. So this is the diagram how reinforcement learning will work. So I already told we have some environment. Environment means we have any interface where we have to perform some action and just win the game. And this is the agent which will move and perform some action here. So this agent will it will do, it will perform the action on the environment. And what will be the output? Will be the state. Means when we perform any action on any state, this is S0 state, and we perform any action A0, so we will reach to next state. We move and we reach to next state, and if this action is correct, we get the reward R0. Reward is represented R0. So what will be the output of this one? State, next state, and the reward. And the reward can be intermediate, immediate, and it can be at the end of the final stage. We can sum up all the reward, and it will be provided to the user. So what is the model? The agent decompose the reward component from the percept. Means I already told the reward can be immediate. If I perform one action, I got the reward, but it can be delayed after the final output. It can be delayed. We get the final reward when all the actions are performed correctly. So two ways are there. So agent can ask to find the optimal policy mapping state to the action and maximize the long run measure. So we have to just optimize this learning. The agent can use some tool to optimize the final reward that have the maximum value actually. So think of reinforcement as a reward and can be modeled as the MTB model. MTB is Markov decision process. So this is the model where which can be used in reinforcement learning for getting the maximum reward. So what is MDP? MDP have this star as a parameter, and we have environment. Environment agent will perform action, and state and reward will be the output here. And this is the structure. We have state S0 and perform any action and have the reward S1, then action A1. So this is the cycle, and the final stage, at the final stage we have the maximum. We just sum up all the reward and get the maximum value. So S is what? Star. S is the set of state. So we have to give one set of state. How many states are there in the environment, and set of action. How much action we have to perform, and then we have the T. This is the target. This is the final probability of transition from S to S dash. So how agent will just get the learning from moving to state S0 to S1, what action have to be performed on which direction. So it will calculate the probability of transition from S to S dash and performing action A. And next is R. R is the expected reward for taking action A in the state. So R will be defined as the probability of transition into probability of this reward. So we will just understand how to compute it. This is the formula actually, how we compute the reward. So we have set of state, we have set of action, we have probability of transition, and we have immediate reward or expected immediate reward received after transition. And here we have the discount factor gamma. Discount factor means if we have moved the correct action and we will getting the reward, then if we are moving all the action correctly, then one discount factor will be there, means it will also add into the reward and maximize the reward value. So next is so the target function is to be learned in this case as a control policy. So we can say reinforcement learning problem is actually different from the other learning problem, and here we have to just approximate. We have approximation of the task as we have some actions on the states and we have just get the reward. So we get the approximation of the task. So what we have computed here, delayed reward or exploration, partially observable states are sensor provide only the partial information, and lifelong learning means this reinforcement learning will be, I already told, will be freeze all the action, and that will be the next experience for the next participant. So how can we formulate this? First is the action are deterministic, can predict the next state, and trained by an expert. Means once agent got the learning, then it will be trained and it will used for learn the new game, or it can learn the new problems. As we play the game, we have different levels. So when we pass one level, we move to next level. So agent can just apply its learning to the next level also. So it will train itself and then can apply the training with onto the next level. So next is Q learning. How Q learning is the algorithm of reinforcement learning. So how it work? It have some steps actually. Here we have some argument like state and action set. So immediate reward for making an action plus base utility. Q means this is a quality learning actually. Q means quality. So we have to just maintain the quality level, means we have to we have input as a set of action and state, and just we have to find out the reward, whether we move to that state with correct action, then we will get the maximum reward. So we have to just choose which state we have to choose and which action we have to choose. This is the actually question. So this will be solved by this algorithm. This is the formula how we calculate the maximum value of QSA. So QSA will be equal to RSA. R means reward at performing any action on the state plus gamma max A Q S dash comma A dash. S dash A dash means that is the next state. A dash is the next action, as this is the next state. So we have to find the maximum value of the reward at that state, next state, and gamma is the discount factor actually. So this is the immediate reward. Gamma is relative value of delayed versus immediate reward. It can be 0 or 1. S dash is the new state after action A, and A dash is the new action we perform to move the state from S to S dash. So this is the final pi S. Pi S is the optimal policy. We find argmax of AQSA. So we get the different this have the maintain the table. So we have to find out the maximum quality learning value. So select an action A to move on to the state S to S dash. Immediate reward R, S dash is the next state, and this is the formula I already told. So we can take one example here. We have given gamma is equal to 0.5, R is equal to 100 if it is moving into the state S6. So this is the starting state, this is the ending state. These are the set of action. Now we have to just perform the action to reach to the end. So we have to just maintain the table. For first action S1, we have the action A12. For S1, we perform A12 to reach to the S2. And reward is 0. S1, we can perform A14, A14 here. So there are two paths, left to right or top to bottom. Next is S2 state, we have two steps. So we have to just find which step we have to move. Firstly, initialize all the reward, and just here we have state action pair. Now we just move to further available actions at S1 are A12 and A14. So if we choose this, so this will be the first value. And now update the table. So S1, QS1 at A12, we perform the action. So reward plus 0.5 gamma, 0.5 plus max. Max means how much next state we getting. So if it move here, we get S2 at S2. It can perform action A21. At S2, it can perform action A25. At S2, it can perform action A23. So there are 3 paths. So here write all 1, and initially all the values are 0. So it will get the value 0. So it get updated. Current position is red. Next we get S2. So similarly we move here and just calculate the value. So QS2 at A23, this one. So if we choose this, we have R plus 0.5. Now we have 2 paths, S32, A32 and A36. So 2 values are 0 here at S3. So we just write here and the reward will be 0. So similar way we update this table. So when we get this one, then the reward will be added. So final reward we get when we reach to this one, A36. So when we reach to A36 at QS2 A36, the reward is 100. So here we get the final stage and we will get the value 100. So now this is new game. Here we again can perform these action again to calculate the new game. For new game, the previous value will be freezed and the award will be, this table is get updated. So we can use the previous reward and can add to the next action if it is performing the correct action. So this is the example. So main keyword is reinforcement learning, task, agent, environment, Q-learning, MDP model, states, reward and target functions. So these are all the terminology used in reinforcement learning. And these are the references you can refer for further study. Thank you.